Very same thing, a little bit different here. We've just got this 4 kips that's going to make this thing go clockwise, which is negative, right? Oh, and where did they ask us to come relative to? Relative to point A. Yeah, that's going clockwise. What's the 5 kips doing? Relative to A, the 5 kips is going counterclockwise, right? Which is positive. So you put the positive value in the equation. This one makes it go clockwise again, negative. That's the only trick to this problem. And you're going relative to A, not this reaction point here or that one. You can take that moment anywhere, right?
So at A, if you got your answer to the right or left, it would be positive or negative.
On that one.
Regardless of whether what your answer really, in reality really was, you'd have, if your answer was positive, you'd be to the right of A. If your answer was negative, you'd be to the left of A. That's how you would
I believe that's right.
Yeah, okay.
Mm-hmm. Okay, now let's see. On 33, what are we doing there? The only difference here is instead of having this 1 kip per foot, we're going to have
Are we not doing the rest of 29?
no. I did it. It's on the blackboard because I want to try to get this squared away here. Some people are going to be leaving here at noon because somebody scheduled a co-op orientation at noon. So
I can ask you questions about that after class.
yeah. So okay, so we've got here we would just have 10 kips, right? Because it's 1 kip per foot times 10 feet, and this value is going to be 5 feet, right? Then we would have this would be what? 28 kips. That distance is 7 feet. So, if you will, this would be 17 feet, wouldn't it? That's that evenly distributed load. Then you do the same thing that we've been doing. You do the 10 plus 28, 38. That's your resultant force. Do the moment about point A. You got negative 50 minus 28 times 17. Add all those up, you get a moment value. To find x bar, you would take, that moment value divided by the 38. And that gives you your number of feet from point A. All right. 34, same thing, essentially. 34, though, notice there's a 1,000-pound force, a 7,000-pound force, and a 200 times 8, right? So nothing real special there. The only thing on that one, let's see, let me move this up. The only thing on that one, when you do your moment, so you'd add this plus this, and then you have a force right here, right? That is what, 1,600 pounds, and then this distance from here to there is 4 feet, right? So then you'd add to do your you'd add 1,000, 7,000, and 1,600. That would be your R value, right? Going down. Then the moment at A equals what? 7,000 negative times 8 feet minus 1,600 times 4 feet, right? 12. I always write it as I'm saying it so that you know I really wasn't that dumb. Okay, may look that dumb, but sometimes I'm not really. And that's it. The 1,000 doesn't belong because it doesn't make it spin, does it? That's why I wanted to show you that one especially. Okay.
Once you get our distance,
Take whatever this value is, divided by that 1,000, 8,000, 9,600. Which that moment a day was 75,200 pounds-feet. Divided by 9,600, you end up with 7.83 feet. Okay? Again, that is posted on Blackboard, so don't go into mass panic.
No, I was looking at the value that you found it the other direction to check it, and that wasn't what I got. But
Well, yeah, and I did the other direction to check it.
yeah,
Yeah.
that's the one I was looking at. I'm looking at it on Blackboard now.
Okay.
That's not 7.83. It's from the other direction.
Right. The other direction is 8.17, wasn't it? Okay, on this one, what you want to look at is you've got a force that's right here, right? That's right at the a third of this distance. Now, this is the only trick on this one. This distance from here to here is 2/3 times 6, which just happens to be 4, doesn't it? 4 meters. Okay, and then that's 7 kilonewtons. 7 times 6 divided by 2, right? To get the force. So what was that? 32. 32 divided by 42 divided by 2 is 21 kilonewtons force at 4 feet. Okay, that takes care of that one. Then you have this force right here, which is 3 kilonewtons times 5, so that's 15 kilonewtons, and the distance from here is 2.5 meters. But if you were looking at these from that point there, you would have what? 7 meters here. And then for this one, be about what, 6, 9, 11 and a half? Right? Okay.
And then one more for that.
Oh, yeah. Sorry, I missed it. Thank you. Yeah, then you have to have this distance here, which is what, 11, 14? Thank you. Yep. So then you do your moment. Of course, you do your R value would be 21, 15, and 10, right? So that's 36, 46. You know what? Did I use 46? Yeah. Thank goodness. Thought maybe I'd forgotten it. So the R value is 21 down minus 15 minus 10 equals 46 kilonewtons down. Sum the moment at A. You got 21 negative times 7 minus 15 times 11.5 minus 10 times 14. Punch that all in, you should end up with 459.5 kilonewton meters clockwise. X bar 459.5 divided by 46 should be 9.99 or 10 meters from A. And then on the solution, I actually draw that so you can see what it would look like.
Well, on the test, are we supposed to have your drawing? No.
On the test, you really ought to have the free body diagram,
But you don't need like what.
and then this stuff here.
Drawing.
But yeah, that when I drew that one at the very bottom
Yeah.
to show what it would actually look like, that was just for your sake. So hopefully that will help you to understand, what am I finding? It helps me. What am I trying to find here? That's what I'm trying. And so I'm drawing that picture just for your sake. You don't have to do that on the test. Okay? Not at all. Let's see, 38, was it any different? Must have been a little bit different. Oh, 38's the couple, right? Okay. And the one thing that will show you that this is a couple problem is the fact that there's no distance from here to here, and there's no distance from there to there. You have to have one of those two if this isn't a couple problem, because you have to solve for a moment relative to one of those 2 points. You wouldn't have enough. Okay? But so that clues you into the fact that this thing is a couple. See, because you got this and this, right? Creates a couple. Those two forces are going to make this thing go, if you're driving the steering wheel, it's going to make it go counterclockwise, right? Which is positive. The 4 kips are going to make it go clockwise, which is negative. So when you do your of course you do your resultant vector, or your resultant magnitude, I guess, minus 10 plus 4 minus 4 plus 10. And if you read what they say in the book, when you do those couples, that will result in a 0. Couples aren't making that thing, they're not putting any up or down force on that beam, if you will. They're canceling out, aren't they? Okay, and you can see that, visibly you can see that. But there's the solution for it.
Would it matter if your 10 kips on the far right side or in between the 4 kips?
The only thing that would matter, it won't matter on this, it would matter on the moment, because it'd be a different number for the distance.
Yeah. Okay.
That's the only thing that would matter. It won't make a bit of difference on this, as long as it's a couple. Notice too, on my solution, I didn't put an A or a B under the moment, because it doesn't matter, because I can't tell you whether it's from A or from B. It's not. It's just a moment. Okay? All of this is making this whole thing twist, one way or the other. We have to decide how it's going to twist. Well, okay, so if I were looking at this from point A, I would have this one making it go counterclockwise, or excuse me, clockwise, which is negative, right? So this is almost like, and let me get rid of this for just a second, because the question is, what's going to be the result of this? There's got to be, it's either got to be twisting clockwise or counterclockwise, even if it's just a couple of couples, or a couple. And we talked a little bit about this the other day. If this force right here, we don't really know what that distance is, but visibly we can see that that's a short number there, right? So, well, and let's look at it from this standpoint. This is how, when Harihar and I were talking about it, we've got, I got to stop and think. Give me that paper, Harihar, because I wrote that down, and I need to do this quick, and I don't want to have to think so hard.
It's not them. It was black forwards and black forwards.
Because I would have had to think about this for 10 minutes. I don't want to have to think that hard. It hurts. All right, so if I draw that picture, I can find my cursor again. I draw that picture, and I've got this force here, F1 left, let's say, and I've got this force here, F1 right, okay, And I'm looking at it relative to this point right here, A. All right? What's going on here? And let's say we've got a distance here, and I made that D2. Let's make it, I'm going to make it D1 just for fun. And I've got this distance here, I'm going to call that D2. Okay? And if I took the moment of just this one, relative to that A, and I said I got the force 1L times D1, which just happens to be smaller, right? And it's, in this case, it's a negative value, right? And then I've got the other force, which is a positive, same vector, or same force relationship, times D2, which just happens to be larger. Which one of these two is going to win? If we put a real number in there, if this was 1 and this was 4, this is going to outweigh this, isn't it? So I'm coming up with a positive value here, right? So when I get done with this, it's going to be a positive value, which means that it's counterclockwise. What's going to happen on this one? Okay, well, and again, if you sub some numbers in here, well, let's see, this distance right here is kind of small, and this one's bigger, right? So that means this one's going to win, right? Which is clockwise, which is a negative spin. But if you add those up, the 10's bigger than the 4, isn't it? The 10 times the distance is going to be bigger than that 4 is. If you add those up, let's do it right here. So if we do a summation of the moment, not at A or B, but we've got, let's see, it was, can't see my numbers there, so I'm going to go here. Negative 4 kips times 7 feet, right? And again, think in terms of how did I figure that was negative? If I draw a steering wheel here, what's it doing? This steering wheel is making that thing go clockwise, right? Then if I draw a steering wheel here, perfect circle, what's it doing? It's going counterclockwise, right? So the negative 4 here, because it's clockwise, plus 10 kips, and the distance on that one was 21 feet. You punch all those in, and you end up with 182 kips feet. It comes out a positive value, so it must be making this thing spin counterclockwise. That's what that problem's telling you. Okay? Ooh, we got 5 minutes. You know what? How about I do this? I will make another video. Oh, sorry, how you get that? I will make a video yet this afternoon or this evening that to explain problem number 42 and 44 in the back of the book. You know, in the problems. Okay, that's the other two that we would do. Now, having said that, yeah, I'll just leave it at that. 42 and 44. So go home and try those. I'll put together a video showing you how to do those two, so you'll have the solution. All right, since we ran out of time. Fair enough? Friday, you get to show off how well you're doing.